All right, today I'm going to be going over a section problem called Battle of Heights. This section problem is going to be really good for reviewing how we use random and a couple math methods like math.round, math.max, and math.min. So the spec for Battle of Heights is that we're at a competition where a group of people are comparing their heights to see who is the tallest and who is the shortest. Each person is going to be randomly assigned a height between 100 centimeters and 200 centimeters. Our task is to write a program that finds the difference between the maximum and minimum heights. The number of participants is again randomly determined, ranging from between 2 to 20. For each participant, a random height will be generated, and the program will then display the height of each person one by one. After all the heights are revealed, the program will identify who is the tallest and who is the shortest, and then we'll calculate the height difference between the tallest and shortest participants to see how dramatic the range is. Once we have done that, we will output the average height amount of all the participants rounded to the nearest number, along with the earlier information we calculated. So that's going to be the tallest height, the shortest height, and the height difference. Here are some example outputs, right? So if we randomize into 3 people, we should print out 3 separate people's heights, and we should number each person we're printing. Then we'll print out the tallest height of the 3, the shortest height of the 3, the difference between those 2, and the average height. So to go about this, I've written some pseudocode here. First, we want to create our random object. This is how we're going to be generating random numbers, which we're going to need throughout the program. Then we're going to generate a random number of people for our participants. That number should be between 2 and 20. Then we're going to initialize variables so that we can track the tallest and shortest height, and we'll update those as we go. We want to initialize a variable to track the total height of the participants. And the reason we're going to do this is so that we can compute the average height, okay? Because the average height is going to be the same as the total height divided by the number of participants. Recall that the spec also specifies once we calculate the average, we want to round it to the nearest whole number. So we're going to have to do that at the end. Once we have all these variables created, we're going to generate a height for each participant and keep track of and update the tallest and shortest heights. Once we're done, all we need to do is print relevant information. So let's start at the beginning. To create a random object, recall that the syntax is going to be random, and then a name for our random object. I'm going to name it rand equals new random. And then recall that in these parentheses, we can put whatever number we want. I'm going to leave it blank. This is our seed. If we leave it blank, it'll be randomly generated. We don't need to worry too much about that. So I've now created my new random object, and I've named it rand. Okay, so now we want to generate a random number of people between 2 and 20. Recall from lecture that the way random works is we can give it one argument. We give it one integer argument, and it takes that integer argument as kind of a range for numbers it can generate. So for example, if I give random the number 10, right? Random is going to generate a random number between and including 0, so it could be 0, and 10 minus 1. So a number between and including 0 and 9. It excludes that extra 10, like that 10th number. So we are actually generating 10 possible numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 different numbers, but we aren't capable of generating the number 10. It goes one below whatever number we provided, okay? So the 10 is kind of like the amount of numbers we want possible to generate, including 0. So 0 through 9 is 10 different numbers. This becomes a little problematic in our problem here because we want to generate a number between and including 2 and 20. As we just discussed a second ago, random is always going to start at 0, so far as we know. We don't really have any easy way to ask random to give us a value between 2 and 20, right? So how can I do this? Well, I can ask random, rather than try to start at 0 or start at 2, and then go to 20. I can just stick with random's rules, and I can ask random to generate me a number with the same range, like the same possible amounts of numbers as I want. So for example, between 2 and 20, and including 2 and 20, there are 19 numbers. So I want to generate between a range of 19 numbers, right? 2 through 20. Rather than do anything weird or try to have random generate from 2 to 20, I can instead ask random to generate me a number that is between 0 and 18. So it still has that same 19 number range, right? There are still 19 possible numbers I could get, but they're just, the range of numbers just isn't between 2 and 20. It's currently between 0 and 18. So how can I take whatever number I get here in this range here and then kind of shift the range over so that we're between 2 and 20? Well, what I can do is I can take whatever number I get and I can add 2 to it. So if I take this range from like random with the argument 19, so I'm going from 0 to 18, and then I add 2, I'm actually going to be getting a number between 2, right here, and 20, and including those 2. So kind of the general formula we can apply anytime we want to generate a random number between 2 points is we can do this. We can take our ending number, which is 20, subtract our starting number from it, and add 1 to get the range of numbers we want. So we need one of 19 numbers. And then we can use this range of numbers as our argument for random. So let's try this in our code here. I'm going to store a new integer variable called participants. I'm going to set it equal to rand.nextInt, because that's the method to get a random number. Remember, nextInt will get us a random integer between 0, and I'm going to say between 0 and 18, so that there's a range of 19 possible numbers, right? Then, once I have that number, which again is going to be between 0 and 18, I'm going to add 2 to it, plus 2. So my range will effectively shift to the right and be between 2 and 20. Okay, so now we have a participants variable, which is going to be between 2 and 20, like we want. Just to be safe, we can test this by making a print statement. And if I run this code a few times, I'm going to get 19, 7, 19, 9. These are all values that would work. I'm not going to test every single value. I'm not going to run the code like 50 times, but just know this will give us a number between 2 and 20. So now that I have that random number, I want to initialize variables for tracking the tallest and shortest height. Let's do that. Let's store them as integers, right? Because heights are going to be in centimeters, and we're assuming here that they're going to be in whole centimeters, okay? So let's create an integer variable, tallest height, and we'll start that as 0, just because we don't really have any heights yet. And we'll create another integer variable, shortest height. We'll start that also at 0, because we don't have any heights yet. All right, we've got both of our variables for tallest and shortest height created. Now let's initialize our variable to track the total height of all of the participants. I'm going to be calling this total height. I'm going to also be starting at 0 because we haven't tracked any heights yet. Remember, the reason we're tracking total height is so that later we can do the calculation of total height divided by participants to get an average height. Okay, now that we have all of our variables, let's go about generating a height for each participant and keeping track of the tallest height, the shortest height, and the total height as we go. First things first, the amount of participants we're going to want to generate height for is going to vary, and we're going to be following kind of the same process for each participant. This sort of pattern where we see code that is going to have about the same process and a number that might vary or it might be repeating over and over is the perfect pattern to let us know, hey, we want to use a loop. We want to use a for loop to do this. So let's write the basic structure for a for loop. Remember, we have for, then the initialization part. Then we're going to put the conditional, the part that tells us when we should keep running our loop, and then the update section. And then we have our 2 brackets, and inside the for loop, the code we want to run each time. For this for loop, I'm going to follow that kind of counting up process we've seen in lecture, where we start our I variable at 0, and then we count up until we're right at the number of times we want the for loop to run, and then we stop. The conditional for this process is going to be I is less than the number of times we want the for loop to run, which in this case is going to be the same as the amount of the participants, because we want to run this for loop 1 time for each participant to generate each participant a height. I'm going to say while I is less than participants, we're going to run the for loop again, if I can spell participants correctly. And then every time the loop runs, we're going to up I by 1. So I plus plus. Remember, I plus plus just means I is being increased by 1. So like this is the same as saying I plus equals 1 or I equals I plus 1. There's lots of ways to write this, but I'm going to use I plus plus because that's kind of an easy convention. It's something we do very common when we have to just up a variable by 1. Okay, now I've got my for loop that should, if I've set it up properly, run an amount of times equal to the number of participants we have. For each participant, we're going to want to generate a random height, okay? And that height's going to be, as the spec says, between 100 and 200 centimeters. We're going to follow the same process of generating a random number between two different bounds as we did last time. So recall the formula we used, right, for the argument we want to provide random is the upper bound, which was 20 in our previous example, but this time is going to be 200, right? Because 200 is the maximum amount of centimeters a participant can be, minus the lower bound, which for the participants is going to be 100 centimeters, plus 1. This math right here for participants is going to give me a number of 101 for my random argument. And then to whatever random number I get, I'm going to add my lower bound of 100 to sort of shift my range to the right. So let's create a random height. Integer height equals rand.nextInt. And remember, we're going to use 101 for our random argument here, plus our lower bound of 100. This will give us a random number between 100 and 200 centimeters. Or I guess I'm calling them centimeters. It'll give us a random number between 100 and 200. I'm going to name this participant height, because this is the current participants we're looking at's height. Now I need to keep track of whether this changes our tallest height or shortest height variable. The way I can do this is I can look at the participant's height and I can check whether it's larger than the tallest height. And if it is, use it. Or if it's less than the tallest height and I don't need to update it. And then I can do the same process for shortest height, where if the participant's height is shorter than the shortest height, we want shortest height to be participant's height. And if not, we want shortest height to stay the same. Now we're going to notice a problem here, because earlier I set shortest height to 0. This is going to be a problem because 0 is always going to be shorter than any of our participants' heights. So rather than set it to 0, I'm actually just going to set it to 201, because that will always be larger than our tallest participant's height. Now, to calculate whether our participant's height is larger than tallest height and store it, we can use one of those math functions we have. Recall from lecture, these are the math functions. And what's going to be useful to us here is the math.max function, which will give us back the larger of whatever two values we give it. So if I were to say math.max, and then I put in tallest height and participant height, this will give back to me whichever height is larger, right? So for example, if tallest height is 0 and participant height is 150, this will evaluate to 150, okay? I have to do something with that number though, right? If I get 150, I know that it is either the same as tallest height or it is larger than tallest height, and I want to update tallest height. So what I'm actually going to do is I'm going to just take tallest height. I'm going to set it to whatever value this gives back to me, right? So if this ends up being taller than tallest height, I update tallest height. If not, then I'm just setting tallest height to itself, so nothing changes. We're all good. Now I'm going to follow the same process for shortest height. But rather than use math.max, we're going to use this other method, math.min, which gives us the smaller of the two values. So I can say shortest height equals math.min, shortest height, and participant height. So if the participant's height is shorter than shortest height, math.min will give us back participant height, and we can update shortest height to participant height. Great. Now we've kept track of the tallest and shortest heights. There's two more things we have to do. We have to update our total height variable, and we can do this by just adding the participant's height to this total height variable, because this total height variable is the total of every other participant's height combined, right? So we're just going to update it every single time we see a new participant. We're going to say total height plus equals, remember that's kind of adding and then setting equal to, participant height. We're adding the current participant's height to total height. And now the final thing I need to do is I'm going to print out the height of the person we're currently tracking. The reason we're doing this now is because we haven't actually stored participant height anywhere outside of the for loop. So once we leave this for loop, we're going to have no easy way to print out each participant's height. So we might as well just print it while the loop is running. So we can just say system.out.println. And I'm going to print out height of person, because this will be the same depending on whatever person is. This like string here will be the same, height of person. Then I need to print out the number of the person we're tracking. Well, we can do this somewhat easily using our for loop variable. This variable is going to be counting up every time the loop runs anyway. So each time we see another person, it will be 1 higher than it was. But we don't really want to start at 0 when we're printing out the height of the person. I could change my loop bounds so that I start at 1. But another easy way to do that, to kind of solve this problem of the fact that I starts at 0, is we could print out I plus 1. Because whenever my loop is on the first iteration, I will be 0, so I plus 1 will be 1. So I'll be printing out height of person 1. On the second iteration, I will be 1, and so I plus 1 will be 2, and I'll be printing out height of person 2. Okay, now I've sorted out how to print out the person's number. I'm going to add this little colon here that we can see in the output. So plus colon, then a space, and then I'm going to print out their height. I'm going to concatenate participant height. So this print statement should print out height of person, the number of the person we're looking at, a colon, a space, and then their height. Before we go any further, I'm going to run this code, and we'll see what happens. We're going to see currently, wow, we rolled 18 participants. This is a very high number. But you'll see we're correctly printing out height of person 1, height of person 2, and then what are seemingly randomly generated heights. So this is good. This means our code is working. One thing we'll notice, though, is because we set up our code this way, we haven't actually yet printed out number of people at the start. This was an error in my pseudocode, but that's okay. How can we go about printing the number of people before we print out everyone's heights? Well, that's pretty easy. Right before the for loop, we're just going to add a print statement. System.out.println. And we're just going to print out number of people. And then we're going to use our participants number as the number of people. Now, if I run this code, we're going to see before the for loop prints everybody out, we're printing out number of people, 6, and then we're printing out the height of all 6 people. Perfect. Our code is looking awesome, right? We're doing all the printing. We've updated total height. We've updated shortest height. Everything's great. All that's left is 2 things. Print relevant information. But one thing I didn't really include in this is to print relevant information, we're going to have to calculate the average height because we haven't done that math yet. And now we have all the tools to do so. Now we have total height having been updated by every participant's height, right? We've added all the participants' heights together, and we have the number of participants. So let's create a variable called total height, or sorry, not total height, called average height. And let's store in it the average of all of the participants' heights. And recall, we're going to calculate that with the total height divided by the number of participants. So average height equals total height divided by participants. Now, we're going to see a little bit of a problem here because recall that total height is an integer, right? And participants is an integer as well. If I try to do division with 2 integers and I end up getting a decimal number, it's going to completely cut off that decimal because of the way Java handles integer division. So to make sure that doesn't happen, I'm going to just, to any of these numbers here, total height participants, before I do the calculation, I'm going to turn them into a double. I'm going to cast it into a double so that I have that decimal information stored. And when I do this division, I will be able to properly account for decimals. So now that we've converted this properly, we'll be ending up with this expression evaluating to a double. But now we have another problem here. If I try to run this code, I'm going to get an error. And it's going to tell me possible lossy conversion to double to an int. That's a lot of weird words. We don't need to know all these words. What we do need to know is it's telling us something's going wrong with the conversion from a double to an int. and it tells us it's happening on line 27. Well, it looks like on line 27, we're calculating a double, and we're trying to store it in average height. But average height is an int, so we're essentially asking Java, hey, store this double in an int. Java doesn't like that. Java's like, they're different types. We want to store it in the same type. So instead of trying to store it as an int, which can't hold decimals anyway, I'm going to store average height as a double. Now, if I try to run this code, it's going to run, but we can't really tell whether average height is, properly evaluating. So to check, we can just system.out.println average equals average height. And we need to add a plus sign so that average height concatenates with this average string. We'll see here, average does properly store a bunch of decimals, which is good. We want to make sure we have the decimals. Later, we're going to have to round it. But to round, we need to know what those decimals are, right? Because we're rounding to the nearest whole number. Integer rounding, like where we cut off all the decimals at the end of a double, is always rounding down. We want to be able to round up if we end up with a number that is above 0.5, right, for our decimal. Before we can print all our information, I now am going to go about calculating that rounded height. So how could we go about rounding a double variable we have? Well, luckily enough for us, our math methods come with a .round method where we can provide a value and it will return the value rounded to the nearest whole number. So let's try that. Let's say int rounded height, or I guess rounded average, equals math.round. We're going to use that math.round method, and then we're going to provide it average height. Now, everything about this code looks pretty good, but if I click run, I'm going to get that same weird lossy conversion error. This is because even though math.round is going to round to the nearest whole number for us, it is going to give it back to us as a double. So it's going to give it back to us, like, for example, if that rounds to 17, it's going to give it back to us as like 17.0, right? To make it a whole 17 that we can nicely print out kind of at the bottom as we have here with no decimal points, I can just take that 17, which now has no decimals other than 0.0, and I can cast it to an int. So I'm basically saying, okay, now that we know we've rounded properly, we can cut off any extra decimals. And if I try to run this code, it will properly run. All right, now we've got all our variables. We can go about printing any relevant information. We've already printed out the number of participants and the height of each participant, and we have a variable to hold the tallest height and shortest height. And those variables have been updated in our for loop on line 21 and 22. So printing them out should be pretty easy for us. We can just do system.out.println tallest height, and then add our tallest height variable. And we can do the same process for shortest height, system.out.println shortest height, and then we can add our shortest height variable. If I run this code, we shouldn't have to do any other work because tallest height is again already updated in our for loop, and shortest height is again already updated in our for loop. And so when we print them out, they are correctly the tallest person's height, in this case 199, and the shortest person's height, in this case 110. To print out the height difference, I can do system.out.println height difference. And I don't have a variable to store the height difference, but that's okay, because the way we can calculate the height difference is just subtract the tallest height from the shortest, subtract the shortest height from the tallest height. And this will give us the difference between the two. So I can just system.out.println height difference, and then in parentheses, so I do this calculation first, tallest height minus shortest height, and then add that to the end of my print statement. When I run this, I'll get tallest height is 199, shortest height is 103, and the height difference is indeed 96, right? Calculation has worked properly. Now for my last print statement, system.out.println, I'm just going to print out the average height, which very nicely, we've already made a variable to store on line 27, and we've rounded it properly on line 27. We created the variable on line 26. We rounded it properly on line 27. So we can just say plus rounded average. And here now, if I run this code, everything is going to print out exactly as we want it. If I click mark, our tests run perfectly. If you have any questions, feel free to email me or post on Ed. Thank you for watching. Hopefully this helped you get some development with your knowledge of math methods and how to randomly generate numbers.